The use of additive manufacturing, also known as 3D printing, is becoming more common in aerospace. For starters, Rocket Lab's Rutherford engines, which have powered their Electron rocket since 2017, are built using this engineering technique. But here's a company that's taken things further than just having 3D printed engines. Relativity Space will soon make history by launching Terran 1, the world's first 3D printed rocket. Let's find out more. First up, we can't believe it's finally happening. This is a huge step for aerospace, you guys. The first stage of Relativity's new Terran 1 rocket is currently sitting patiently on the launch pad while crews conduct a series of tests. The company announced an important milestone in late July. It hot-fired all 9 of the rocket's Aeon 1 engines simultaneously for the first time. After that, Relativity Space will conduct what's known as a mission duty cycle test before integrating the rocket's first and second stages. What's important here is that before they launch, they want to ensure the system is performing within the expected range. So we want to think of it as a pre-flight checklist. You want to ensure that each system meets its qualified data and that the design engineers who worked on these systems validate their data. Relativity previously conducted a similar test of one of its Aeon 1 engines in December 2020 at NASA's Stennis Space Center in Mississippi. Teams ran the engine at full power for 187 seconds during that test, demonstrating that the engine could operate in a flight-like configuration. Relativity Space is looking to build on its own legacy as it moves forward with 3D printing rockets from a site with such a rich history. With each subsequent launch of the Terran 1 rocket, the company hopes to produce more and more of the rocket using its additive manufacturing capabilities. The scale differs from other industry providers that have 3D printed components because folks at Relativity are 3D printing not only tanks, but also their engines. They're also attempting to achieve a 95% printed vehicle. Terran 1 is currently 85% printed en masse. Next, we'll tell you more about Relativity Space. Tim Ellis and Jordan Noon founded Relativity Space in 2015 with the goal of creating all things rockets using additive manufacturing. They also wanted to help with putting humanity on a path to becoming multiplanetary, a goal shared by other companies such as fellow launch provider SpaceX. As early as 2018, the company was a venture-backed startup with more than $1 billion in memorandums of understanding and letters of intent. The majority of its additive manufacturing takes place in its 120,000 square foot headquarters and Factory of the Future, which houses Stargate, a collection of the world's largest 3D metal printers. The manager of launch operations at Relativity described this as disrupting 60 years of aerospace because what the company offers is a radically simplified supply chain. Because of their software-driven manufacturing and 3D printing techniques, they can build a rocket in 60 days with 100 times fewer parts. Relativity collaborated with NASA and the U.S. Space Force to develop its launch infrastructure. At SSC, they've got 2 testing facilities for engine and stage testing. They have access agreements with the United States Space Force to both the Cape Canaveral Space Force Station in Florida and the Vandenberg Space Force Base in California. Relativity also upgraded Launch Complex 16 at CCFSS, which had previously been used to launch the Titan 1, Titan 2, Pershing 1A, and Pershing 2 missiles. Now, what do they mean by good luck, have fun? This will be the company's first mission, and it'll serve as a test for both the rocket and the team at the Cape. Officials at Terran decided to fly the first Terran 1 rocket without a payload and with a nose cone on top of the integrated vehicle rather than payload fairings, which will be featured on the next launch. Because this launch will not include a customer payload, the mission has been dubbed Good Luck, Have Fun. This mission will provide the team with valuable insight as members prepare for launch number 2, a mission as part of NASA's Ventura-class Launch Services Demonstration 2 contracts. In 2020, NASA's Launch Services Program at Kennedy Space Center chose it as one of 3 companies to launch a series of small sats in support of the CubeSat launch initiative. According to an August 2021 SLP presentation, Relativity's second mission is the educational launch of Nanosatellites 42. At the time, NASA stated that the launch date would be late Q2 CY 2022. It'll launch one more unnamed customer before the Terran 1 undergoes a block upgrade to convert the rocket from 9 Aeon 1 engines to a single Aeon R engine. NASA awarded Relativity Space's Terran 1 rocket another launch contract in January 2022, this time as one of 12 Venture-class acquisition of dedicated and rideshare missions. Terran 1 has a number of other contracted launches coming up, including rides with Spaceflight, Momentous, and Iridium. Next up, what's Relativity got under their sleeve? Despite all the preparations and the work on the Terran 1 rocket, Relativity Space is already focusing on its second rocket, the 3D printed and fully reusable Terran R. The company intends to begin launching it in 2024. It can carry 20,000 kilograms to low Earth orbit, which is 20 times more than the Terran 1. As of June, 5 customers had signed on for Terran R missions, such as the multi-launch agreement with OneWeb to support its growing communication satellite constellation. It's currently worth approximately $1.2 billion and includes multiple launches. Its most ambitious mission to date is a collaboration with Impulse Space to deliver the first commercial payload to Mars. It's a significant step forward, not only for the company and commercial space exploration, but also for the advancement of additive manufacturing on and off Earth. That path is now wide open thanks to 3D printing. If we can 3D print a vehicle, we can then apply that technology to other infrastructure, other technologies that'll allow us to build that base on Mars and elsewhere. Truly a marvel. Coming up, this exciting revelation can take 3D printing even further. According to engineers, we could 3D print tools on Mars made from the planet itself, and the exciting experiment could change the future of space travel. The breakthrough means that future missions will be able to print essential repair items, such as spare rocket parts. It's a significant discovery because researchers claim that they can't bring everything out to space, and if they forget a tool on a mission, they obviously can't return to get it. Getting materials out there is also prohibitively expensive. According to the study's authors, it costs $54,000 to place 1 kilogram of material into Earth's orbit. As a result, researchers at Washington State University in the United States believe that 3D printing is an exciting field that could be the answer to making space travel more affordable and accessible. Small amounts of simulated crushed Martian rock combined with titanium alloy created a strong high-performance material that could be used to make tools and rocket parts on Mars. They created tools out of 5% to 100% Martian regolith, a black powdery substance designed to mimic the rocky inorganic materials on Mars' surface that could be collected by a robotic arm or rover. When only 5% Martian dust was added to the mix, there were no cracks or bubbles, and it performed far better than titanium alloys alone. They believe that this combination could be used to create lighter weight pieces that can still carry heavy loads. Since then, space agencies have become increasingly interested in 3D printing, and the International Space Station now has its own devices for producing materials on site for experiments. And lastly, this has broadened the horizons for many other breakthroughs. The best thing about technological advancements like these is that it opens up a whole new world of possibilities. Many aerospace organizations are now in the race to one-up Relativity Space, one of them being in India. Global space companies such as the US-based SpaceX and Rocket Lab have achieved consistency and scale in satellite launch with their rockets, which India's space startups will seek to emulate. Agnikul Cosmos, a private space startup in India, has obtained its first patent for the design and manufacture of its 3D printed rocket engine. The patent was made available to the company through the center's patent database. It comes shortly after the company opened its first factory to 3D print rocket engines at scale. The company was awarded the patent for its Agnilet rocket engine, which will power the company's Agnibon rocket, which is set to launch later this year. Each of the company's rockets, which are billed as ultra-lightweight satellite launch vehicles, will require 8 engines. Agnikul's factory, which opened in July, currently has the capacity to produce 2 rocket engines per week. This equates to producing the engines for 1 rocket within a month. Agnikul isn't the only Indian space startup that uses 3D printing for its parts and components in the country, though. Skyroot Aerospace employs 3D printing for the rocket engines that will power the company's Vikram satellite launch vehicles. It also recently raised $50.5 million in the largest single funding round for a South Asian space startup. As they say, the sky's the limit. That's a wrap for this video. What's next for 3D printing in the aerospace industry? Let us know your thoughts in the comments below. As always, don't forget to like this video and subscribe to our channel for more videos like this. See you in the next one.